Hello and welcome to the second Easy 11 Plus lesson, and this week we're going to be concentrating on mathematical sequences. If you find this lesson useful, please click like underneath the video, and please also subscribe. When you subscribe, you support me in what I do, but it also means that you find out about other videos that I post on this channel. There's a worksheet for today's lesson in the description underneath this video. If you haven't completed it already, I really recommend that you do the questions in the worksheet before you watch the rest of this video, and then you'll get a lot more out of it. I'd like to introduce Hans. Hans is a cat. He's a German cat with 3 degrees from the University of Heidelberg, and he's very, very good at maths. He can count all the way to 2, and he also has strong opinions about it, and I expect that we'll be hearing a little more from him during the course of this lesson. Is that right? Yeah. Okay. I'll put you down for the moment so you can go away and solve some equations. Right. Let's get started. So, these are the first questions in the worksheet, and as you can see, getting rid of some cat hair, as you can see, these are a pretty common type of questions that you'll encounter in an 11 plus exam. Cat hair everywhere. So, let's have a look. Now, the first thing you need to do with something like this, rather than just plunging in straight away, is to look at the differences. So the difference from 3 to 5, of course, is 2. And the same difference from 5 to 7, and the same difference from 13 to 15. So we can very clearly see where the sequence is going. It's going to be 9, it's going to be 11, and there we have it. It's a really easy one, but always get into the habit of writing these differences. It can be really useful when these sequences get trickier. Right, minus 33 to 6, that's tricky. Let's skip to the end. 102 to 129, well, 2 to 29, you can see that's 27, so let's write that in. And then, let's check whether there are the more difficult ones at the beginning are also 27. So minus 6 to 21, so minus 6 to 0 is 6, and 0 to 21 is 21, so that's 27 in total. Okay, so we can see the pattern. It's 27 in each gap, and indeed minus 33 to minus 6, it's the same difference as 6 to 33. 33 minus 6 is 27. Okay, so now 21 plus 27. Now you could go over here and write 21 plus 27, and sorry about my handwriting on the screen, and work it out. But in fact, it's pretty simple as a mental arithmetic problem, and get into the habit of doing it for these very simple things. 21 plus 7 is 28, plus 20 is 48. Okay, now 48 plus 27, 48 plus 7 is 55, plus 20 is 75. Now, don't just stop there, let's check that it all matches up. 75 plus 7 is 82, plus 20 is 102. So that does take us all the way to 102, so it's correct. Okay, 10, 11, 1, 11 to 15, 4, 65 to 101, 36. How do I do that quickly? 65 to 71 is 6, and 71 to 101 is 30. Right, now this may look very tricky, but when you're doing an 11 plus exam and you come across a sequence that goes up in big jumps like this, there are 2 things that you need to think about straight away, and these are the possibilities of square numbers and cube numbers. Now let's think about square numbers for a second. So what's a square number? You may know this, but let's do a quick revision check. So a square number, if we imagine a square like this, we imagine the sides are 2 and 2. Now the area of that square is going to be 2 times 2, which gives us 4. So 4 is a square number because it's formed by timesing the same number by itself. 2 times 2 is 4. 1 is a square number because 1 times 1 is 1. 4 is a square number because 2 times 2 is 4. 36 is also a square number because 6 times 6 is 36. So, if we've got 1 and then 4, what's 3 times 3? It's 9. 4 times 4? 16. 5 times 5? 25. And as we've seen, 6 times 6 is 36. Now, these aren't the answers, these are just the way that we get to the answers. So, 15 plus 9, 24, and 24 plus 16, 24 plus 6, 30 plus 10 is 40. And then we need to check it, of course. 40 plus 25 is indeed 65, so that's the answer. Just a quick bit of revision. If that's a square number, what would a cube number be? Well, a cube number is, if you imagine, rather than a square, a cube. Full test of my drawing abilities here. Here's a cube. It could be worse, just about. So if you imagine that it's 2 high, 2 wide, and 2 deep, 2 times 2 is 4, times 2 is 8. So the volume of that cube will be 8 whatevers. So you might have the area of the square being 4 centimetres squared, for example, and this might be 8 centimetres cubed. So that would be a cube number, but that isn't relevant here. Anyway, pushing on. Here's another very similar style of question. These turn up so often in 11 plus exams. 3 to 7 is 4, 7 to 11 is 4, so this is easy peasy. 19, 23 and 27. Don't get carried away with these. Do take the time to make sure that you're writing the right answers in. It's amazing how many people lose marks by making silly mistakes, such as thinking, I don't know, that 15 plus 4 is 20 or something like that. Just take the time to make sure that you're right. 53 to 46, well, we're going down by 7. And here we're going down by 6, and we're going down by 5. I think you can see what the pattern is. So we've got 4 takes us to 31, 3 takes us to 28, and 2 takes us to 26. Now, you'll be starting to see how useful it is to write the differences in, because without writing the differences here, you could easily, for example, look at the beginning and say, oh look, the difference is 7, and then just start taking off 7 each time. So you'd have 28, 21, 14, and you'd be wrong. Always take the time to write in the differences, and then you won't make those silly mistakes. Right, 1 to 2, 1, 2 to 4, 2, 4 to 8, 4. Look, the differences are doubling each time, so it's going to be 8, takes us to 16. This is going to be 16, takes us to 32. This is going to be 32, takes us to 64. But if you look at this again, you'll realise that actually you can do it without writing in the differences, because not only are the differences doubling, but the numbers themselves are doubling. So 1 doubles to 2, 2 doubles to 4, 4 doubles to 8, and so on and so forth. So that's actually, in the end, a fairly simple one. But I think you can see from these two here how useful it is to write the differences in, because rather than just staring at the question and thinking what's going on, if you just start straight away by writing the differences, you often find your way into the answer without actually needing to apply too much thought. And when you're in an exam and it's stressful and you're worried about what other people are doing and you're worried about the clock, just having these simple techniques makes life easy and unstressful, and perhaps above all else, saves you marks. Let's power on to the next question. Here are some patterns of dots. I'll make this a bit smaller so you can see it clearly. The pattern is continued. You can complete the table below. Now we could just plunge into the table, but if they're going to give you pictures like this, it's worth spending a little bit of time to understand them properly. So if we look at this, we can see that the first pattern has 4 dots. The second pattern has got the 4 dots from the first pattern and 3 more. And the next pattern has got the 4, 5, 6, 7 dots from the previous pattern and 3 more. So without even looking at the numbers down here, you can see that we're adding 3 dots each time. And indeed, if you look at number of dots down here, we can see that going on. We're adding 3, we're adding 3. So of course, the next one's going to be 13, and the next one is going to be 16. Easy peasy. Okay. How many dots would you need for the 120th pattern? Let's keep it so we can see the table and have the working space. How many dots would you need for the 120th pattern? This looks really tricky. Hans, do you have any ideas about this? Anything useful to contribute? What's the answer to this question? 9? Okay. Hans, the answer, the 5th pattern has got 16 dots. How can the 120th pattern have 9 dots? Sometimes I wonder whether you know what you're talking about at all. I don't think we can take this cat's advice very seriously. So let's move on and think about this ourselves. Now, this is a kind of question that really scares people, and it's relatively common in the 11 plus. But it doesn't need to be scary. I'm going to explain how it works and how you can work out the method that I'm about to explain for yourself. But if you don't remember the why, make sure that you remember the how. Because if you could just do this method and repeat it whenever you see a problem like this, then you'll be able to solve the questions, even if you don't fully understand it. But do make the effort to understand. Right, we need to work out a rule so that we can get to the 120th pattern without writing the number of dots for pattern 6, pattern 7, pattern 8, pattern 9, pattern 10, pattern 11, until we get to pattern 120, by which time it's the end of the exam. We need to find a better approach than that. So, let's think about this. The pattern number, which we need a simple label for this, it's number with n, so we're going to call this n. Mathematicians are very creative. Goes up by 1 each time. That's obvious, but let's just bear it in mind. Now the number of dots goes up by 3 each time. In other words, this increases 3 times as fast as n increases. So to write that in a mathematical way, we might say that it's to do with 3 times n. And as I'm sure you know, in maths, when you've got a letter times by a number, you don't need to write the times, you can just write 3n. I've left a space after this. Maybe you can work out why. If not, you'll find it very soon. Now, what happens if we take this 3n thing seriously? So if n is 1, what's 3n going to be? Well, obviously it's going to be 3. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. And 3 times 5 is 15. Can you see the pattern yet? All of these are 1 less than the number of dots. So the number of dots isn't 3n, which is these numbers here. The number of dots is actually 3n and 1 more. 3n plus 1. So that's an expression, a mathematical way of explaining an idea with letters and numbers that describes the number of dots based on the pattern number n. So for example, if the pattern number is 3, then n is 3, so 3 times 3 is 9, plus 1 is 10, and that's our number of dots here. So this expression is a really useful tool that gives us the number of dots based on any pattern number. Now, if you haven't fully understood how I've done this, then I suggest rewinding the video, watching it again, maybe having another go at the question until this method is really, really imprinted in your mind, because it will be extremely useful, not only for the 11 plus, but for all manner of maths that you do in the future. So learn this, it's worth it. Right, now, how do we actually answer the question? The answer is not going to be 9, as Hans asserted. Let's think about it. So, for the 120th pattern, that means that n is going to equal 120. So 3n plus 1 is going to equal 3 times 120 plus 1, which is going to equal, so how do we do 3 times 120? 3 times 100 is 300, 3 times 20 is 60. Again, there's nothing wrong with writing 120 times 3 and working it out, but if you've got the mental arithmetic to do this, it will save you time. I should say, by the way, that let's say at the beginning of the exam was actually a question that says, work out 120 times 3, then you should write out the method because they might be marking that as well. In a question like this is your working out that they're going to mark, and so you don't need to waste time by writing out little calculations like that. Anyway, 3 times 120, 300, 3 times 20 is 60, so that's 360. Plus 1 equals, drum roll, 361, of course. So, in the 120th pattern, there are going to be 361 dots. And of course, always remember to write your answer in the answer space, unless you really, really don't want the marks. Okay, Now this is a question that I've added because although it wasn't part of this question I found, it is something that sometimes turns up, and so it's important that you know how to do it. This is another question to come back and revise to make sure that you understand this part of the video and you can just reproduce these techniques. The actual algebra is really simple, but working out which algebra you need to apply and how to make it relevant to the question is something that just needs a little bit of practice, a little bit of familiarity. Which pattern would contain 120 dots? So remember, our expression is 3n plus 1, where n is the pattern number. Now last time we knew what the pattern number was, it was 120, we just plugged it in instead of n. In this case you can't do that. What we know is that 3n plus 1 is going to give an answer of, 130. Strange way to write a number starting with the middle one, but anyway, middle digit, but there we are. So, now, if you can solve an equation like this, even if you don't have brilliant, fluent algebraic technique, you just need to think about it kind of sensibly. So, 3 times n and 1 more gives us 130. 3 times n and not 1 more is therefore going to be 129. Now, 3 times n is 129. I'll write that out in full, just so it's absolutely clear what's going on. 3 times n is 129. So 1 times n is going to be a third of 129, if you think about it logically. Now, you may just be able to do that in your head, but there's really no shame in doing a little division over here. 129 divided by 3 gives us 4. Don't worry about the 1, 3 clearly doesn't go into that, 3 does go into 12 4 times, and 3 goes into 9 3 times. And there we have it, that's the answer. Equals 43. Okay? Now there isn't an answer space down here. You need to make it clear to the examiner that you know which thing in your solution is the actual answer. I do it just by double underlining like this, dead simple. That's clearly the answer. If you just single underline, it might look like you've done the top part of a fraction and forgotten about the bottom or something like that. So double underline is dead clear, dead simple. Don't worry about it too much. Just a few quick things about what I've done here. Might as well do a little bit of algebra recap while we're at it. When you're solving an equation like this, you always need to do the same thing to both sides of the equals sign. Some people call it like balancing the equation. Just remember, you always do the same thing to both sides. So for example, in the first row here, to get to the second row, we subtracted 1. And we subtracted 1 from both sides. Now, why were we subtracting 1? Because we want to know what n is at the end. So we need to get rid of the things on the n side of the equation that aren't to do with n. So the first thing we can get rid of is the plus 1. So we're left with just 3 n's and no number rubbish. So we get rid of the 1 by subtracting 1 from both sides. But then we want to know what 1n is, and here we've got 3 n's. All lurking on that side of the equation. So we need to get rid of 2 of them. Now, we can't take away 2 n's because there aren't any n's on the other side of the equation to take away. So instead, we have to divide by 3 n's. We've got 3 n's, we just want 1, so we divide our 3 n's to get 1n. So we divided by 3, that gives us n, and we have to divide 129 by 3 because we do the same thing to both sides of the equation. And that gives us 43 in the end as our solution. Now, another little thing here, notice that there's an equal sign in the middle of each line, but there isn't an equal sign at the start of each line. Why is that? Well, that's because 130 does not equal 3n equals 129. If I've got an equal sign here, I'm saying that 130 equals 129, which is nonsense. It doesn't, okay? So no equal signs like that. Also notice how I've lined up all the equal signs, even with my extremely messy writing. And to be honest, my writing's really messy even when I'm not writing on a screen, but this doesn't help. How I've lined them up like that so I can clearly see what's going on down each column and make sure that everything matches up and I'm not making any silly mistakes. Last thing that I'm going to say about this, sorry if it's getting boring, but it's super important. Last thing I'm going to say about this is that my extra working out here is well out of the way. Here, I've got the solving of the equation. And that's a thing in its own right. Over there, I've got my extra working, which is not part of the equation solution. It's just like I've taken some notes, keep it well out of the way so it doesn't get mixed up and confuse things. Right, enough on that. If you haven't got these methods completely down pat, if you need to go over them again, just pause the video, maybe have another go at writing your own answers on the worksheet, and then come back to the video and watch that until you really understand it. And if you still don't fully get it, maybe leave it for a few days and then come back to it, and you'll get there. It isn't complicated, you just need to get familiar with the method, like anything of this sort. Okay, right. Now, this question gives you a lot of instructions. When you get instructions like this, don't just go blah, 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 where's the question? Read them properly and understand them, because if you do properly understand them, then the rest of the question is likely to be relatively straightforward. If you don't read the instructions properly and understand them, then there's a risk that you'll make a complete mess of the rest. So, a sequence of numbers which get multiplied or divided by a fixed amount each time is called a geometric progression. Okay? You don't really need to know what it's called to do this question, but it's useful knowledge. For example, the sequence 6, 12, 24, 48 is multiplied by 2 each time. 6 doubles to 12, 12 doubles to 24, 24 doubles to 48. So it's times 2 times 2 times 2. The first term of a geometric progression is 8 and the second term is 24. Work out the third term. Okay, so we've got 8, then we've got 24, then we need to times that by 2 and we're going to get 48. So the answer is 48. Yeah? No. I hope you're all screaming at me. Absolutely not. Just because the example up here involved multiplying by 2 each time does not mean that each part of the question is going to involve multiplying by 2. It's going to involve multiplying by something each time. But there's no reason to think that it's going to be 2. And in fact, to get from 8 to 24, you should know your times tables. Perhaps you saw my tip of the week in last week's lesson. To get from 8 to 24, of course, we are timesing by 3. 8, 16, 24. And so the third term is also going to involve multiplying by 3. Now, you might be able to do this with mental arithmetic, because you might say 20 times 3 is 60, 4 times 3 is 12, 60 plus 12 is 72. But of course, there's no shame in going 24 times 3. And while it's really good if you've got very reliable mental arithmetic to do it that way because it saves time, don't use the mental arithmetic method just because you feel you should if you aren't completely secure with it. It's much better to take a few more seconds and do it this way and definitely get it right than to power through doing mental arithmetic and make silly mistakes. The main thing is to get the correct solution, obviously, but sometimes these obvious things aren't so obvious. Okay, so the answer is 72, and of course, don't forget to write it in the answer box. Whenever I write something in an answer box, I always take a moment to ask myself, have I included the units? So, for example, does this question need centimetres or grams or something like that? Of course, in this case, it doesn't. We're not talking about units of anything. They're just numbers. But always stop to ask yourself that, because if you do miss out the units when they're required, you'll probably lose a mark or half a mark or something that you really don't want to lose. Okay, pushing on to here. I'm going to blow some cat air off this monitor, excuse me. No help with maths and leaves fur everywhere. The first term of a geometric progression is 20 million and the second term is 2 million. Woof, they're big numbers. Work out the ninth term, and 9 is also quite a big number. That suggests we're going to be writing out quite a few terms here. But stop, let's see what happens. So 20 million to 2 million. Let's ignore the word million. Let's just think about 20 and 2. So if I want to get from 20 to 2, what do I multiply or divide by? The answer, of course, I've lopped off the 0, which means that I have divided by 10. Just as if I times 20 by 10, it would become 200. You're adding and removing zeros when you multiply and divide numbers by 10, unless you're dealing with decimals, of course. We'll come to that a little bit later. So 20 to 2 is dividing by 10. So the same will apply to 20 million to 2 million. You're also dividing by 10 to get there. Now, you could work this out by writing 20 million, whoa, and then writing out 2 million, and then writing out 200,000, and so on, but you've got an exam to do, and this is going to take a long time. So let's think about how you could do this more efficiently. And part of doing a maths exam well is knowing maths and, not getting held up. Part of doing a maths exam well is finding efficient ways to get to the answer, not just by guessing and writing the answer without working. Writing working is really important because, first of all, in some exams they're going to mark the working anyway. It's not that common, but it certainly happens, and it's quite common that there are some questions where they require working and they actually normally indicate it, they say show you're working out. But even more importantly, let's say that you get the answer slightly wrong. If you haven't given proper working, you lose all the marks. If you get the answer slightly wrong, but you provided some working that at least has some good things in it, then you'll probably get some marks for that working. And that can make the difference between getting into the school you want to get into and not getting into it. So writing working is super important. Anyway, that's an aside. So we've got 20 million again. Why did I rub it out? I've just made life more difficult for myself. 20 and 6 more noughts. Now, that's going to be the first term. We want the 9th term. That's going to be the 2nd term. That's going to be the 3rd term, 4th term, 5th term. You probably know about tallies. You do 4 vertical lines, then swipe across for the 5th. Where are we? 6th term. 20 is the 7th term. 2 is the 8th term. Oh, hang on a second. We haven't any noughts to take off, and we need one more term. How do we divide 2 by 10? Well, we've got the decimal point here at the moment. We need to take it across one more place. So put it there. So it's going to be 0.2. So the answer is 0.2. You could also do it by saying what's 2 divided by 10? Well, it's a fifth. And if you wrote a fifth as your answer, that would also be correct. No problems at all there. If you wrote 2/10 as your answer, you'd risk losing maybe half a mark because you haven't simplified it down to a fifth. 0.2 or a fifth. Okay, so in the end that isn't too difficult a question. And what I've done here is perfectly acceptable working. It's really clear what I've done. Anybody marking this, I should put that in the shirts the 9th term, anybody marking this would see this, understand and give credit if they needed to review my marking in some way. Right, powering on. So this of course was a bad answer. Another one here. Right. The first term of a geometric progression is 8, and the 3rd term is 200. Work out the 2nd term. Right. I hope I read that with enough drama. So, often with a question like this, you're going to stare at it and think, what do I do, what do I do, what do I do? Don't do that, just start writing stuff down. So here, I'm just going to write out what's going on here. The first term is 8, then there's something, and then there's 200. And I know that with the geometric progression, I'm going to be timesing by the same amount each time. So this is going to be times, whoops, that's a very messy time symbol indeed. I think I can do better than that. Even I can do better. So it's going to be times something. What should we call the something? Just come up with a letter name. I'm going to call it y. And then we're going to be timesing by y again here. Oh, goodness me. I need to go into handwriting training. I'm sure there are hundreds of people watching this who could teach me how to write better. Right, okay, so I'll pull it down so I don't need to reach so far up the screen. Right, okay, so 8 times something gives us something, times that by the same something, and you get 200 too many somethings. Now, one way to do this, and a perfectly reasonable way, is just using an approach called trial and improvement. That's more sort of familiarly called trial and error, but trial and improvement is a more mathematical way of putting it because you're not just guessing randomly, you're working in carefully towards the answer. So, for example, let's say that we try timesing by 10. Imagine that y is 10. So we'd have 8, and then we'd have 80. Whoops, I'll put commas in here. And then we'd have 800. Whoa, that's much too big. Okay, so that isn't right. Then we say, okay, we've got to go, that's far too big, so we're going to go much lower. So then we say, okay, what about 8 times 2? So we got 8, 16, 32. And that's far too low. Okay, so we've gone far too high, we've gone far too low. What are we going to do about this? Okay, let's pick it up a bit. Let's try times 4. So we've got 8, 8 times 4, so 8, 16, double that, 32. And then times that by 4, so 32, 64, 128. Still a fair bit too low. Okay. We could try by 6 or 7, but let's just try 5 because it's a pretty easy one to do. So we've got 8. 8 times 5 is 40. By the way, timesing by 5 is really simple because you can just times by 10 and then half it. So 8 times 10 is 80, so times 5 is 40. A lot of mental arithmetic is just about these little tricks. Different people develop different little tricks. You'll find what works best for you. So we've got 8, 40. 40 times 10, 400, so times 5 is 200. Aha! That is the answer. So we have to times by 5. So the answer is 5. No, it isn't. Because we need the second term, not what you times by. The second term is this. So the second term is 40. This is a really, really important point. It's super common that someone flies through a solution to a problem and then they find the answer and they're relieved, and then they write down the wrong thing. They write down some key part of their working and not the actual answer. Don't make that mistake. Don't be that person. That person is somebody like me. Don't be me. Right. Okay. Now, we found the answer to this question, but of course there is a slight problem with this. Well, not with this, but there's a potential problem with this method. Let's say that you didn't have to times by 5. Let's say that you actually had to times by 4.62. Now, how many options would you be trying as you tried to narrow in and get to that precise answer of 4.62? You might be at it for hours, and there'd be some really difficult calculations along the way. It would be really inefficient, and it definitely wouldn't be appropriate in an exam. So this is one of these questions where, while trial and improvement, which we've got here, is a really good method, and for this question it's ideal, it's also worth thinking about how you might do this with a bit of algebra. If you're comfortable with algebra. If you're not comfortable with algebra, the method I've shown you is absolutely fine. And to be honest, in an 11 plus exam, the answer isn't going to be that you're timesing by 4.62. But I'll show you this anyway. So we've got 8 times y gives you 200. So let's write that out. Times y equals 200. Now, remember the square that I drew earlier on. Promise you that's a square. With y times y gives you y squared, just like 2 times 2 gives you 4. So 8 times y can be written as 8y squared equals 200. Now, what's 200 divided by 8? Just to save time, I'm just going to tell you it's 25. How do I know that so quickly? Because 25 goes into 104 times, so it goes into 208 times. Y squared is 25. So we need to work out what times by itself gives 25. So y equals, and I'm just doing this to show you another useful symbol, equals the square root of 25. That means what squared gives 25. And of course you know the answer to this, it's 5. Okay? Now if you use this method, it's then super tempting to go, yes, I found the answer, and write 5 in the answer box like I did before. But don't fall into that trap. Before you write the answer, always recheck the question to make sure that you found the right answer and that you haven't misunderstood something about the question. This is an always thing for any kind of maths problem. Always reread the question before you write the answer. So this says, what is the second term? Aha, I found out what you need to times by. So we go back up to here. We say 8 times, we know that y is 5. 8 times 5 is 40. And now we can write that up here. Easy as that. So 2 completely valid methods, either is fine. If you're comfortable with algebra, algebra will always get you straight to the answer with a question like this without you need to worrying about the answer being complex. Yes, there might be a slightly tricky calculation if it's a difficult decimal, but you'll get straight there. Trial and improvement is also a really good method as long as you're fairly sure that the answer is going to be something fairly simple and that there aren't going to be any really fiddly numbers along the way. For this question, that's a pretty safe guess, and so trial and improvement would be a perfectly acceptable method here. It's always an acceptable method, it's just it can take you a long time if you use it in the wrong circumstances. Right, here's the next question, but before we do it, I think to give you a little pause, we're going to take a moment out to cover today's tip of the week. So to give us a break from maths, I thought I would talk briefly about a really common concern with English, which is spellings, because a lot of people come towards their 11 plus exams and they're still making a ton of spelling mistakes, and they think, there's nothing I can do about this. I learned all my spellings before I started 11 plus preparation, back in years, 3, 4 and so on. If I don't know them now, if my smelling is a disaster, I hope not, but my spelling's a disaster now, there's nothing I can do about it anymore. There are hundreds of words I'm getting wrong, I'm losing a ton of marks in everything I do. It's just something I have to accept. It isn't. Almost anybody can make an enormous difference to their marks for spelling with a very small, genuinely a very small amount of work. Because it works like this. If you've got problems with your spellings and you lose a lot of marks for them, what's probably happening in practice is that you're making the same spelling mistakes again and again and again and again. Because what we all do is we always tend to reuse the same relatively limited vocabulary of common words that we like to write a lot. And if we don't know how to spell them, then we're making the same mistakes a lot. Now, if you write out a list, if you go through your recent pieces of written work and create a list of the 40 or 50 spelling mistakes that you make most commonly, just 40 or 50, even 30 or 40 really, do what you can, but don't make it too many, make it an easy number. And then memorize the corrections perfectly. So let's say you've got 40 spellings, you just spend a couple of weeks where every day you work really hard writing out the correct spellings, writing out some sentences with them in, getting someone in your family to test you on them, until you know them perfectly. You'll probably find that your spelling in a real piece of work improves by 95%, literally quite possibly 95% or more, because those 40 most common mistakes will actually be almost all the mistakes that you make. And what's more, if you learn those corrections, you'll also start correctly spelling other words which have similar spellings, where you would have made similar mistakes. So you'll actually improve the spelling of way more than your 40 or 50 words. So that little bit of work, taking the time to make that list of your most common spelling mistakes and learning them really, really well, can make an enormous difference. Even if your exam is 2 weeks away, do that now, learn those spellings, and you'll save a lot of marks that you would otherwise have lost. Right, there's no escape from maths. Let's get back into it. So, this is a truly horribly difficult question, and you might say this wouldn't turn up in an 11 plus exam. Well, it did. It turned up in this 11 plus exam from St Paul's Girls' School. Admittedly, they set harder questions than many other schools, but it's an interesting question, and even if you won't be confronted with a question like this, once you get used to thinking about it, how this kind of sequence problem works, and once you understand it, you'll also do a lot of other things in maths better. And that's one of the reasons I like difficult, sort of slightly weird questions, because they get you thinking and they stop maths just being a matter of mechanically doing this method, then doing this method, and they turn it into something where you're being creative and really playing with ideas. So let's have a look at this. Right. Miller adds odd numbers together and writes down her result as follows. Okay, Miller has an unusual hobby, but I heartily approve. So 1 equals 1 equals 1 squared, 1 plus 3 equals 4 equals 2 squared, 1 plus 3 plus 5 equals 9 equals 3. So look, she has found a way of making squared numbers. We might have spoken about these already today, which is not completely obvious, but it's quite interesting. So the idea that 1 plus 3 plus 5 gives you 3 squared. And so we can reasonably guess that 1 plus 3 plus 5 plus 7 would equal 4 squared. In fact, I'm going to give a little bit more space here. 4 squared. What is 4 squared? 4 times 4 is 16. Because you can see the first one's got one number, 1. The second one's got 2, 1 plus 3. Third one's got 3, 1 plus 3 plus 5. Fourth one's got 4, 1 plus 3 plus 5 plus 7. Let's just check this to make sure we're along the right lines. So 1 plus 3 is 4, 4 plus 5 is 9, 9 plus 7 is 16, so it works. Okay, we've got to write down the next 3 lines. By the way, underlining things in questions is a really, really good idea. It helps you to concentrate on what's really being asked, and it helps you to avoid misunderstanding a question or missing out parts of it. So I really recommend doing this. I should probably have done it earlier on already, actually. Right. Next line, notice I'm lining these up. Even though I'm messy, I try to keep a good structure to the way I put my answers together to minimize mistakes. 1 plus 3 plus 5 plus 7 plus 9 equals something equals 5 squared. 5 squared, 5 times 5 is 25. Now, I'm not going to check it by adding all these up this time. I think we're sure enough now that the pattern works. We're in an exam. We have to make some decisions about where not to waste time. And we've got to do one more line. 1 plus 3 plus 5 plus 7 plus, I'm sure it's exciting to watch me doing this, plus 11 equals something equals 6 squared. And of course, 6 times 6 is 36. I think we came across that earlier, actually. Right, so dead simple, that's this one. Just notice how I've lined the numbers up to keep it nice and clear. Now, that's going to be useful later on, as you'll already know if you've already done this question, and congratulations if you did, found the answer to the last part of this question. Okay, using this pattern, write down the line which consists 169 at the centre. Whoa! But, deep breath, don't panic. So, we can already see that each line contains... Ooh, I can't work out how to explain this. Let's just demonstrate it. When the answer is 3 squared, it's got 3 numbers over here. When the answer is 5 squared, it's got 5 numbers over here. So, if, for example, it was... Oh, trying to rub these out, because we might need this answer space later on, as you'll see. If, let's say that we had an answer that was 31 squared, then we know that we would have 31 numbers on the left. 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 7, and so on, until you had 31 of those numbers would equal whatever it is equals 31 squared. Right, okay, using this pattern, write down the line which contains 169 at the centre. So, 36 was 6 squared, 25 was 5 squared. 169 is what squared? Well, what do we know? We know 10 times 10 is 100, well, that's a bit too low. We know that 12 times 12 is 144, that's really close. So, pretty good guess that it's 13 times 13. And indeed, if you imagine 13 times 13 in a multiplication problem, 3 times 3 is going to be 9, so it ends with 9. So really, very, very likely indeed, but no harm just checking it over here. 13 times 13, have I left enough space? Oh, we're going to find out. 3 times 3 is 9, 3 times 1 is 3. Then we start the second line with a naught at the end, don't forget, very important. 1 times 3 is 3, 1 times 1 is 1, just enough space. So we got 9, 6, and 1s. Of course, it is 13 squared. So 169 equals 13 squared. Okay, so we know we're going to have to write out 13 numbers. Okay, this is the boring bits you watch me. Let's do it very quickly. So we're going to have 1 plus 3 plus 5 plus 7. Normally doing things very quickly with me means you can't read them, but I'm not doing so badly. Plus 13. I'm just going to keep writing a few and then I'm going to count how many I've done. We definitely haven't done 13 of them yet. Plus 19. Oops, that's a 9, not a 19. Plus 21 plus 23, let's stop and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, almost. Plus 25. Right, just because you don't want to lose a silly mark, I'm going to count them one more time to be sure. 1, 2, 3, 4, 5, 6. 11 is the 6th. 1, 2, 3, 4, 5, 6. 23 is the 12th. Plus 1 is 25, so that's 13 of the numbers. Okay, great. So, in the end, that was quite simple, but you just have to keep an eye on what the pattern is, that it's going to be whatever squared it is the number of numbers, so you need to know 169 is what squared. A little bit of basic knowledge of your squared numbers tells you that it's going to be something in the 13, 14, 15-ish, and so we get here. By the way, you could have got there a bit more quickly, actually. So 12 squared is 144. 13 squared is going to be an odd number, and it's going to end with 9. So, pretty good guess it's 13. 14 squared is going to be an even number, isn't it? Because 4 times 4 is 16, it's going to end in 6. And 15 squared is going to be something something in the 5 times table. So really the only one it can be out of those numbers is 13 squared. That's another way of thinking about it. Right, anyway, powering on. We don't want this lesson to run on for hours and hours and hours. Already been doing it for, about 45 minutes. Anyway, so Miller then adds different odd numbers and puts the results in a table again. She just won't let go of it, this Miller. So, next 3 lines of this pattern. Now this is different. So we've got 1 equals 1 equals 1 cubed, which of course, we already covered this, but as a reminder, 1 cubed is 1 times 1 times 1. Now it doesn't really matter what you times 1 by, so how many times you multiply 1 by itself, you're still going to end up with 1. It could be 1 cubed, it could be 1 to the 5, it doesn't really matter. But anyway, that's 1 cubed. 2 cubed, 2 times 2 is 4 times 2 is 8, and so on. So it's numbers times by themselves and times by themselves again. Remember that sketch of a cube I did earlier where you had the height times the width times the depth. Right, next 3 lines of this pattern. This goes 1, 3, 5, 7, 9, 11. This is interesting, a bit of a different pattern. So rather than starting with 1 plus 3 plus 5 each time, 1 plus 3 plus 5 plus 7, we're actually carrying on 1, 3, 5, 7, 9, 11. So the next one is going to be 13 plus 15 plus 17. And now we need 4 numbers this time. 17 plus 19. That's a bit messy, never mind. Main thing is that the person marking it can clearly read what you've put. The problem with messiness is when it tips over to actually not being clear that it isn't obvious what you put. Maybe it isn't obvious, that's a plus, so I'm just going to make it a little bit clearer. No harm doing that. Okay, equals something equals 4 cubed. Okay, what's 4 cubed? 4 times 4 is 16. 16 times 4 is 32, 64. So equals 64 equals 4 cubed. Okay, now the next one is going to end up as 5 cubed. And that means it's going to have 5 numbers in it. So we're going to start a little bit earlier along. It's going to be 21. Oh, that's a 3. Ouch. Okay, 21, because we finished the last line with 19. 21 plus 23 plus 25 plus 27 plus 29 equals something equals 5 cubed. 5 times 5 is 25, 25 times 5, whoops, 25 times 4 is 100, 25 times 5 is 125. Okay, and now the next line here. I know this bit is not so exciting, but of course you're watching this as a video. You could already have skipped past this bit if you wanted to, so more fool you if you haven't. Don't worry, I know that nobody watching this is a fool, probably. 31 plus 33 plus 35 plus 37 plus 39 plus 41 equals something equals 6 cubed. Let's just check we've got 6 numbers here. 1, 2, 3, 4, 5, 6. Yep. Okay, 6 cubed. So 6 times 6 is 36. What's 36 times 6? Let's just do a quick multiplication to be sure. Still not leaving myself enough space. Some people never learn, not just cats. 6 times 6 is 36. 6 times 3 is 18, plus 3 is 21. So, lo and behold, 216. You could also do it by thinking, what's 30 times 6 is 180, because 3 times 6 is 18. And what's 6 times 6? 36. 180 plus 36 gives you 216. But to be honest, unless you're really confident in your mental arithmetic, I think that probably doing this here is a little bit safer. Just reduces the room for silly mistakes. Okay, using this pattern, how many numbers do you need to add together to get 1,000? Now, you're not given very much information here, so it may look really off-putting, but don't be put off. This one isn't actually that difficult. So we know that 1,000 is going to be something. Let's call that x, because we used y. Oh no, drawing on the screen is hard. Excuses, excuses, you say. Right, 1,000 is something cubed. Now, what we really need to know is how many numbers are going to be here. But of course, we already know that whatever x is will be the number of numbers. If you remember, for example, looking back here, we had 5 cubed, and that meant that there were 5 numbers there. So the same thing applies here. Whatever x is, that's going to be the number of numbers on the left-hand part. Now, 1,000 is something cubed. Well, this is full of noughts, so what's the first thing we're going to try? I mean, so if we tried 100, for example, what's 100 cubed? Well, hang on, 100 times 100 is already 1 and 4, already 10,000. So if you times that by another 100, you're clearly well outside the range that we need here. So that isn't right. Let's try 10. So 10 times 10 equals 100, and 100 times 10 equals, lo and behold, 1,000. So, in fact, 10 cubed is 1,000. So let's just write that out clearly, so we're showing some clear working. 10 cubed equals 1,000. And therefore, how many numbers do you need to add together to get this row of this pattern? The answer is 10 numbers. Simple. Okay? Now, while we're here, I just want to point out a super common mistake that I think pretty much everybody makes at some point when they're learning maths. And obviously I don't get annoyed by anything, but if I were to be annoyed by something, this is a mistake that would probably annoy me. So it's when people write 10 times 10 equals 100, and then rather than then starting again saying 100 times 10, they write something off and show it here. They say 10 times 10 equals 100 times 10 equals 1,000. Have you ever done that? If you can honestly say that you never have, then have the genius gold star. You've probably done this sometime. Let's look at it. What this says is, you don't forget equals means is the same as. This means that 10 times 10 is the same as, oops, that should be a times, it's looking like a plus. What on earth am I doing? What it's saying is that 10 times 10 is the same as 100 times 10. What? It's also saying that 10 times 10 is the same as 1,000. Really? Of course not. You can't put a times here. 10 times 10 equals 100, and then you have to do a new thing that says 100 times 10 equals 1,000. In maths, the equals sign is sacred. The equal sign means these things are exactly the same. No ifs and no buts. Do not misuse the equal sign. It's just a very bad thing to do. It'll lose you a squazillion of marks and annoy maths teachers. But it's just a really horrible way to treat numbers. Don't do that to them. Right, onwards. And now we get to the grand finale. Because this is a real zinger of a question. It's an absolutely horrible question. And I rather like it. I think it's quite interesting. What I like about this question is that it doesn't require you to know some really clever maths rule. It's a question about how well you can think through what you've done before and find something intelligent to do with it. But if I look at this question, first of all, my first response is probably going to be to stare at the page a bit and think, this is really horrible. What's going on? So, using your answer from parts A and B, and I'm probably going to do something like this with my hair at the same time, cunningly exposing my armpits to the people at the neighbouring tables in the exam, and thereby gaining myself an advantage through a form of chemical warfare. But, so, using your answers from part A and B, now that's something I like, because that's telling me what to do. It's telling me to look back through the rest of the exam. But, when I try to draw my screen, there we are, it's working, I didn't recognise my pen thing. Okay, using your answer for part A and B, find 3 numbers A, B and C such that, and what people are like to do is they're likely to stare at this and go, A minus B equals C. A squared minus B squared equals C cubed. So we've got 3 different letters, we've got squares, we've got cubes, we've got 2 equations. Wow! And it's very likely you're going to look at this and you're going to turn to your mental hands and you're going to say, what do I do here? And it's likely that your mental hands is going to say something like, and you've got a bit of a problem if your cat is German and the answers come out in German. But I believe Hans is telling us to solve the equations. Well, we've got 2 equations, we've got 3 letters we don't know, and we've got 11 plus maths knowledge. And taking all these things together, in fact ignoring the 11 plus maths knowledge bit, we've got something we can't do anything with. We can't solve these. We can't just plug them together and come out with an answer. It's not going to happen like that. And yet again, Hans has provided us with a really terrible piece of maths advice. If there's one lesson that you're going to take from today's session, it is that you should never, ever listen to your cat's advice about maths, and possibly not about anything else either. Hans is actually sitting up very indignantly. I think I've offended him. He's turning his back on me. I'll have to make it up with him afterwards. You can't see him. He's curled up on a blanket just behind the computer. Okay, so we've got these. Let's just check what they mean first of all quickly. A minus B equals C. So for example, that might be something like 4 minus 3 equals 1, for example. 4 is A, 3 is B, 1 is C. A squared minus B squared equals C cubed. So that would be something like if I said, I don't know, 9 squared minus 4 squared equals something or other, call it P cubed. Now, the trouble is 9 squared minus 4 squared is 81 minus 16, which gives us 65, and 65 is not a cube number. So, just by plugging random numbers into this, you're really going to be very lucky if you find the answer. I'm going to rub these out because these are not the answer, they're just random numbers, and I wouldn't want them to be sitting there if someone was marking this thinking that I thought that was actually part of the answer, because it probably wouldn't impress them enormously. Right. We, of course, have to use our answers from parts A and B. By the way, you may wonder why I'm taking so long talking about how I look at the question and explaining what's going on. That's because I wanted to make clear that there are certain ways of looking at a question, for example, fixating on the letters and thinking, I must solve equations and do algebra, which are not helpful. On the other hand, what is really helpful is to take the time to understand what these equations mean. What does it mean to say a squared minus b squared equals c cubed? If you understand that properly, you'll be in a position to go into the rest of the question. If you don't understand it properly, you're going to make a complete mess of it, whatever you do next. So take that time and don't listen to cats. Using your answers for parts A and B, of course, means we need to look at parts A and B. Now, I'm not going to do a split screen here because I need enough space to draw on. Remember, in your mind, especially this. A squared minus b squared equals c cubed. In other words, take away a squared number from another squared number and get a cube number out of it. That's what we need to focus on. And then we can come back to this business here and check whether it fits or not. And if it doesn't, try again. So, let's look at our answers to parts A and B as the question instructs us to. So, here's part A. Here we got the squared numbers. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, all that kind of carry on. Now, we know that we're going to have to start subtracting from square numbers from each other. So let's just play with it. Let's try subtracting some square numbers and see what happens. So for example, let's look at these two up here. 2 squared minus 1 squared. Now you could say, of course, 2 squared is 4, 1 squared is 1, 4 minus 1 is 3. But let's just look at the numbers on the left, because these are being provided here. They must have something to do with what we're doing here. So if I want to subtract 1 squared from 2 squared, I'm going to take 1 away from 1 plus 3. So taking that away. So then we find out that 2 squared minus 1 squared equals what we've got left, is 3. And of course that's right. 4 minus 1 equals 3. So that works. Okay, rub that out. Don't want to clutter up the page. In fact, because I'm working for a different answer over the top of my working here, I'm going to be swanky and change my pen colour just so that there be no confusion about what I'm doing. If you're in an exam, you need to be a little bit careful about writing working for a later part over your work for an earlier part of a question. It's absolutely fine to do it, but make sure that you don't accidentally cross out any of your working for the earlier question or cross out the answers, because then you're going to have big problems. You don't need to use a different colour, just make sure that your working in your answers to the original stuff is still completely clear. I'm sure the marker will understand that you're doing working for the later part. They'll already have marked dozens of these scripts probably, and they'll know what's going on. In fact, they probably set the paper, they're probably expecting it. Anyway, blah, blah, blah. So let's try something more complex. Let's try, for example, 4 squared minus 2 squared. So that's going to be this here. Da-da, red colour. So here, we're going to be subtracting 1 plus 3. So 2 squared is 1 plus 3. So if we want to subtract these, we're going to take that away from 4 squared. Now, this is an example of something you shouldn't do in an actual exam. Don't go crossing out parts of your working. I'm doing it here in a different colour. I'm going to get rid of it later. Well, probably not actually, but in an exam, don't do this. You need to leave your original working intact. This is the kind of working you might write out in the answer space below or something like that. The circling is okay. The crossing out is not okay. Careful. Anyway, so we're left with 5 plus 7. So now we know that 4 squared minus 2 squared is 5 plus 7. Let's check that. In fact, let's write it out. 4 squared minus 2 squared equals 5 plus 7. So 4 squared is 16. 2 squared is 4. So 4 squared minus 2 squared is 16 minus 4, which equals 12. And 12 does equal 5 plus 7. So you see, the method works. Now, in an exam, you might not be doing all this. You might be racing through a little bit faster towards actually answering the question. I'm doing all this for anybody who's just looked at this and really hasn't understood it, and I'm building it up in stages so that you really know what's going on. Obviously, in an exam, you need to be more attentive to time and working efficiently than I do when I'm just recording a well, maybe I should be paying more attention to efficiency because this is getting a bit long. Right, anyway, never mind, at least we're learning maths. I'll make it shorter next week. We'll do some reasoning or something and not spend so long over it. Okay, so this is an example of how you can do it here. But we are not just subtracting square numbers at random and hoping a cube number pops out. We are looking for a cube number. And fortunately, we've already got some hints about it down here because we know what cube numbers look like. Yes, they look like this stuff here. But, more usefully now, based on the method we've been playing with, they have this kind of structure here. And that's possibly going to be useful for us. So let's just remember these 1, 3 plus 5, 7, 9, 11. So can we subtract two square numbers so that something like this pops out at the end of it? Can we do it so we're left with a 1 or a 3 plus 5 or a 7 plus 9 plus 11 or something like these more complicated ones down below? But let's see whether we can keep it simple. 1, 3, 5, 7, 9, 11. Remember those. Well, looking at this, I can straight away see this. 3 plus 5. So, let's get rid of this working out now. That's the advantage of doing it with an electric pen, that you can't do it in an exam. Okay, so 3 plus 5 is going to be a cube number. 3 plus 5 is going to be 8, which is 2 times 2 times 2, which is 2 cubed. So if we can just be left with that, we're going to have a cube number. So what can we do to 3 squared to be left with 3 plus 5? Well, we need to get rid of the 1 over here. So, how can we get rid of the 1? Well, 1 squared is 1. So if we do 3 squared minus 1 squared, we'll get rid of these 1's, and we'll be left with 3 plus 5, which equals 8, which equals, oops, 2 cubed. Now hang on a sec, we also need, if you remember, a minus b equals c. So if 3 squared minus 1 squared equals 2 cubed, ABC, also 3 minus 1, whoa, this is messy, equals 2. Isn't really an equal sign, it should be, but anyway, shh, don't show it to a mathematician. Okay, so this fits. This is an answer. So we got it. Right. Now, you need to make sure you've got some working in the answer space down below. This is all fine. It hasn't messed up our working over here. So you don't need to get rid of this, but we do need some in our answer space just to make sure that the examiner is going to be happy with us. So you can go for fairly minimal, and you can even write something like C above, C working under part A. If you write something like that here, that's fine, it will help, but you do still need, stop throwing stuff around in my excitement. You still need something here, but we can keep it relatively simple. So we know that, in fact, I need to check back up there again because I've forgotten. Talking and remembering at the same time, not my forte. Okay, 1 plus 3 plus 5. So yeah, 3 squared minus 1 squared. Got it? So I would write something pretty simple like this. 3 squared minus 1 squared equals 1 plus 3 plus 5 minus 1, which equals 3 plus 5 equals 8, which equals 2 cubed. So we've got A, B, and C. A squared minus B squared equals C cubed. And then we also know that, and I'm going to write this out with the same vertical alignment to make it clear, we also know that 3 minus 1 equals 2. A, B, C. So it works. And of course, don't forget to write your answers in the answer box down here. 3, 1, 2. No squares or anything. 3 squared minus 1 squared equals 2 cubed, but A itself is 3. So don't write the squares or the cubes in the answer box. And that's how you solve it. Now, there is, if you look back at parts A and B, at least one more correct answer to this question that pops out. I'm not going to tell you what it is, I'm just going to tell you that it's there. So if you want to practice this technique, go back into parts A and B and see whether you can find another set of values for A, B, and C that also work with both these options. And if you find the answer, why not post it in the comments and I'll tell you whether you're right or not. We're there. We've made it to the end of this rather long session, but we've covered some really important maths, and I hope you found it useful, and I hope on occasion you've at least enjoyed it, and I hope you enjoyed working through the questions. It's been lovely to see you today. Please like the video. If you've survived this far, it must be because you find it useful, so please also click subscribe, and please tell your friends about this channel. I'll be back at 6 p.m. next Tuesday, hopefully without technical problems. And I haven't decided on the topic yet, but it won't be maths. And I look forward to seeing you then. So, bye-bye.